Hello, everyone. I would say how you doing, but I cannot hear a word you say. So if you're doing bad, just put your hand up and do that, and then we can talk about it later. No, everyone's good, brilliant, excellent. Oh, there's one. We'll talk later anyway. Okay, thank you for coming back. I think you've had lunch and breaks and things, so you actually come back to hear me speak, which is a really good thing. I feel very blessed that you actually turned up. Welcome to my spare room. This is always the best place to share new knowledge and new stories. Has anyone seen me speak before? Raise your hand if you've seen me speak before on chaos engineering. Oh, excellent. Not many. So I could completely reinvent myself if those people that put their hand up can keep quiet for a little while. So I'm going to try and do that. So I'm going to share my screen now so I can show you some slides. They're not most exciting slides, but I do want to point out what I'm going to share with you today is something I've not shared with anyone else outside of my sort of immediate circle of people. So you were the first people to hear something that I think is it's a profound change in chaos engineering that's coming down the pipeline that I hope you'll be interested to hear. So let me share my screen and move over to the slides. Okay, I'm going to do that one. Can do share. And then we do that. And I think then everyone should be able to see it. I'm going to make sure I can see everybody. Thumbs up if you can see it, okay? Excellent. We're in good business. Right, okay. So this talk is one of a rare breed of talks from me where I don't put chaos engineering, front and center in the title. And that's because, like I said earlier, it's a little bit of an evolution of the technique. It's a little bit of a change. But don't worry if you've not done any chaos engineering before, or even if you've not read the principles of chaos. I'm going to give us a bit of a grounding first before we get rolling into what all that stuff means and where it's going next. Okay, so for those of you that don't know me at all, I'm on the motorcycle in this picture. I always use a picture of a motorcycle to introduce me because it's closely related to chaos engineering. It's closely related to the sort of, I guess, the worldview that motorcyclists have as opposed to people who drive other forms of transport. And let me explain that quickly. So this will give you a bit of a foundation on the chaos engineering anyway, because chaos engineering starts with a mindset. It starts by thinking differently about the systems that we run. The motorcycle analogy is this, right? So if you've ever had a driving lesson and you drive a car legally, therefore you've got a license, you will have probably been taught to drive defensively. And what that usually means, this is how it was explained to me back in the day, was if you're out on the roads, assume everybody can't see you. Assume that everybody, drive like everyone's blind, and you'll be safe. You'll be safer that way. It's a good little rule to have in your head, okay? Motorcyclists are not taught this. Instead, what we are often taught is assume everyone can see you and they want you dead. If you assume that the entire environment that you're surrounded by is out baying for your blood, then you'll not just ride defensively, you'll ride completely differently than you would have done if you made any assumptions that anyone was not out for your blood. And that's how we stay alive longer. That's how motorcyclists stay alive longer. And so this was me riding a motorcycle through, I think that's Tibet, but it was Nepal and Tibet. And this all became very, very apparent to me then, because you don't just drive defensively, you drive incredibly carefully when you're on roads around the world. And this is how I tend to think of chaos engineering. Chaos engineering is a realization that production is not your friend. That production is the least likely place that your wonderful code, your wonderful ideas of observability and run books and incident management, all of that comes into play and fails, or frequently fails, perhaps, is one way of looking at it. And chaos engineering is a recognition of that. Chaos engineering recognizes that we can prepare better if we recognize that this is a hostile environment that we place our code in. And when I mean a hostile environment, I'm referring to the whole system. It's the people, the practices, the processes, the technologies, your cloud providers, the internet at large, your users also hate you, and they want your holidays ruined, and they want you to be in on Sundays and Sunday evenings and all that sort of good stuff. So chaos engineering embraces this. It goes, okay, that's the challenge. That's the way the world is. How do we be better at being prepared for these sorts of occurrences, these sorts of conditions? So, okay, I've written a few books on this just to mention that there are some things I've done on this. Good place to start. Obviously, I'm going to say that is the Learning Chaos Engineering book, but I do mean it. It's a good place to start. It's a good place to get to grips with what this all means. The Chaos Engineering Observability book that I wrote for Humio is more for those that are running chaos experiments at scale, where the observance of chaos experiments across an organization becomes a problem or becomes a challenge. So it's a scaling mechanism and pattern, really, rather than learning chaos engineering, which is really you in a team, what should you do to get started? Now, one of the little confessions I'm going to bring up a little later on is why the Learning Chaos Engineering book is fabulous. Of course, I'm going to say that, but also how much I've learned that I would put in that book now if I was writing it now. So there's some new stuff that I would love to go back and do an edition to or something similar on in that book. And I'm going to share some of that with you over the course of this talk. The last thing that I've written on recently is I contributed to the book by Casey and Nora. They curated this book of stories. And in there, you will see, if you ever get hold of it, that there's my position on chaos engineering is that it's a scientific, empirical, disciplined approach to exploring systems, and it requires collaboration. That's going to come up important later on as well, because when people first encounter chaos engineering, they tend to think it's just breaking things, it's just injecting failures. But when you start to see the social dynamics around what chaos engineering contributes to, you see that there is a huge amount of collaboration that is not just useful, but necessary to get the most out of the technique. So I'll be talking a little bit about that later and how we can do more now that I've got the realizations that contributed to this talk. Okay, so I get asked a lot, what do I essentially do? So I say I help companies build and run reliable systems and secure systems using chaos engineering. That's the tagline. But essentially what I really do is I help people turn beliefs and hopes into evidence and learning. That's pretty much it. Because of my whole grounding, if you like, foundation for the last 6 odd years in chaos engineering, what I do is I go in and I don't believe much. When someone says a system will work this way or that way under these conditions, I don't always believe it. In fact, I rarely believe it unless they've got evidence, unless they've got something to back up their claims. The amount of companies, actually I had a great conversation quite recently with a cloud provider where they said, we know what will happen when this part of the system fails. So we don't need chaos engineering. We know what will happen if this part of the system fails. And I said, let's unpack that word know, because I told them that I specialize in turning belief and hope into evidence and learning. What does that word know mean to them when they say it? And I said, so have you seen what happens when that particular part of the system fails? And they said, well, not yet, no. I said, but we know what will happen. We know what runbook will come into play. We know who's going to be involved. We know. And I said, okay, have you ever done it? No, we haven't yet, but we know. We know. And when you unpack it, that word know is usually a replacement for we strongly suspect or we believe, really. And with chaos engineering, with this sort of scientific empirical hat on, we go, okay, I don't believe anything until we've seen it. We've seen how this plays out. And that's where the sort of heart of chaos engineering comes into it, is we're getting better prepared for failures in systems because we explore them before time. We learn from them before the crisis, before the expensive situation. And this is obviously in reaction to the fact that companies have these sorts of conditions happening all the time. Systems fail. It doesn't matter how fabulous your team is, how wonderful your technology choices are, until it all comes together at that moment in production where a stampede event happens. Your marketing team strike gold and everyone arrives, and then you find out what really is going to happen. It's not just stress testing. It's not just flooding the system with traffic. It's frequently going, what happens when something doesn't work the way we expect it? What really occurs? And the way I talk to business people about this, I say, look, we're getting better prepared for this. I'll help you explore, adopt, and practice stuff that is proactive. We're going to be better at this before the problem occurs. And I use fancy phrases, right? So resilient capabilities is one of them, capacities. I help them develop capacities. What do I mean by that? It means I help through practice, through chaos engineering practices, I help them explore their belief to find evidence of what capacities they really have. When a particular set of turbulent or problematic conditions occurs, what really goes down? You know, one of my favorite stories is always about game days I've done. I love to share game day stories. If anyone here hasn't done a game day, please do game days. It's one of the simplest techniques in the chaos engineering pantheon. In fact, it predates chaos engineering. But to do a game day, well, one of the things you get out of a game day is you really get to explore how the people react to a set of conditions. And one of my favorite stories here, and I can't remember, but I can't share with you the company, unfortunately. But I turned up for to meet up with Casey Rosenthal, who created chaos engineering. I was meeting up with him in London, and I walked in to meet him. We were meeting him at a separate company, some other company. And as we walked in, they'd just done a game day and they'd just broken a decent chunk of production. And watching the reactions of people, observing how the system responded. Yes, it was very painful. Yes, everyone was quite stressed, but the learnings from it was massive. And everyone agreed that game days were massive for that preparation. They were seeing their capacities come to light, their true capacities come to light. Are they good at anticipating the problem? Are they good at synchronizing, reacting, and eventually learning from it? These are the resilient capacities that we develop when we start to do chaos engineering. And really, at the heart of it, if I was to be asked truly what I try and do with the various companies that I work with, is I try to develop a culture of reliability, trying to shift it left slightly in a very careful way, because I'm very wary of the word shift left, because shift left just sounds like some poor team is having more stuff dumped on them. But what we're trying to do is shift left reliability in a very careful way, in a proactive way, so that a team can truly take responsibility for it. And that's one of my personal little missions in doing this. You'll see that in the way that I talk about chaos engineering. I rarely talk about a chaos engineering team. There is no separate team in most of the companies I work with. There's really an encouragement that the existing teams consider taking some of this additional responsibility on as sensitively as possible to the demands they've already got. If you haven't seen it already, this is just the standard stock phrase of what chaos engineering is. And I usually bring it up to point out the little contribution that I made to it, which is by removing the word distributed from the original definition as it was on the principles of chaos. Mainly because a lot of the customers I work with, the clients, when I work with them, they don't always have what they would call a distributed system. It is distributed. Most things are distributed to some degree or other now. And if you don't think yours is, if you're running on any sort of cloud native public cloud system, you're distributed, you're on their stuff. So you have a distributed system regardless. You have all of the complexity usually of a distributed system. But I wanted to remove that word because I didn't want people being turned off chaos engineering just because they didn't consider what they had as being distributed. But you can see here sort of the hammering the point home of what it's all about, which is we're trying to build confidence in a system's capability to withstand turbulent conditions. Turbulent conditions are surprising. They're often unknown. They can be unknown unknowns. And in which case, what we're doing is we're building confidence in our capacity to deal with what's going to come along. And I do that very simply by helping organizations explore, verify, and learn from these things through proactive experimentation. This is all you need to know about chaos engineering. It's proactive experimentation. It's being ahead of the curve and going, okay, what happens if this happens to the system? Let's, in some small way, perhaps, let's try it. Okay, so to sort of frame the main point I want to leave you with from this talk, I need to talk about common themes that I've seen in chaos engineering across all the different companies I've worked with. And these are common pretty much regardless of the size of the company, regardless of the size of the team, whether they are truly going cloud native or whether they have a very hybrid approach. Even one of my clients is running mainframe and bits and pieces. So some of these things are really spread out in terms of their applicability. But I wanted to share some common things because there's some common things that happen a lot across the organizations, because then I want to frame what we enable with the new ideas that are coming along. Okay. So number one, common thing, being proactive. That's a key thing, right? Rather than going, we're only going to learn from incidents. That's great, by the way. Everybody should learn from an incident. There's a great quote from Casey Rosenthal, which is, every outage is an opportunity to learn. It's really something that's true. We can take an incident and learn so much from it, and we should. However, if we only learn from incidents, I have an analogy for that. The analogy is that's kind of like learning to drive on the Autobahn at 120 miles an hour, and that's your first lesson. Good luck. We're in production. Let's learn how it's going to work. You will learn, but the chance of fatality is pretty high. So the risk is massive on learning. Instead, with chaos engineering, by being proactive, by doing these things in a controlled and disciplined way as experiments, we're trying to learn before we're on the Autobahn. We're trying to learn in the car park first. Can we just get around? Can we do a 3-point turn or a parallel park or whatever we have to learn these days in cars? So we're trying to do that with our training wheels on. That's what chaos experiments start as, is can we be proactive about it? Can we look at our reliability and how the system responds before the big crisis? Just before I move on to the next common theme, I just want to make sure we all understand what I mean when I say reliability and resilience, and I may occasionally mention the word robustness a little later on. Reliability, in my view of the world, is something that's very much judged from two perspectives. One perspective gets much more attention than another. There's the reliability of a system from the perspective of the consumer of the system. That's when you look at SRE and you look at SLOs and other bits and pieces, that's what they tend to focus on first, is how does the system look truly measurably from the user's experience? Because it's the user that is the ultimate judge of reliability. Do they rely on your system, and can they rely upon it? That's where the root of that comes from. There is another perspective, though, is the people working on the system, the people responsible for it, the people that interact with all the fabulous dashboards and observability and interrogatability and making sense of everything at runtime. Can they rely on that? So there's always a consumer of the system. And it's that relationship that we look at when we're talking about reliability, the relationship to a consumer and the system they rely upon. And of course, system here is a very broad word. It can be absolutely made up of people just as much as it could be made out of pods. Now, moving along the list, we go to resilience. Resilience is your system's capacity to anticipate, synchronize, respond, and learn from conditions it interacts with. So the ability for it to encounter often unknown unknowns and react well. We'll often say a human being, a person, is particularly resilient because stuff's happened, it's been hard on them, but they've handled it, they've gone through it well. The last one is robustness. Robustness is what we usually inject into a system for known things. As an example, we might set up a database with 3 nodes to give ourselves some fault tolerance and an HA configuration. That's robustness. So the interesting here is chaos engineering, and this being proactive is about exploring all of those things. It's about exploring the reliability, the perception of or impacts on reliability from the consumer's perspective. It's also looking at the robustness that we have in the system. Is it truly going to play out that way? That robustness that we think we've injected for the knowns, is that going to happen? Is that going to play out as we expect? And the same with resilience. Are we going to anticipate and synchronize and react well? Are we going to see how that plays out? Is this whole system come together, and then do we learn from it as well? Is something we can also measure. But that's what being proactive is one of the common themes. Mindset and practice, I mentioned earlier, a huge part of chaos engineering. Thinking differently about your systems, not assuming they'll work. In fact, assuming that more often than not, they'll try not to work. I can't tell you just how jaded you become. The more you know about chaos engineering, the more you do it, the less trusting you become of guarantees from SLAs. SLAs are wonderful, but by the time you rely on them, everything is already in trouble. So with chaos engineering and proactivity, the mindset is we're going to take responsibility for this ourselves. We're going to explore it ourselves because we don't have to rely on belief alone. And we're going to practice it regularly to make sure we continue to maintain that confidence. This is another common theme is resilience. There's a couple of ways of looking at it. We mentioned capacities, which I'll talk about in a sec. But one way of thinking about resiliency is, and what it relates to chaos engineering, is we proactively prove that we're better prepared. We can see it. We can see how these scenarios play out, and we can see that you and the system can respond well to those things. Okay. And really what I'm doing with these common themes, what we see across all these different organizations is the payback, the payoff is in better learning loops. We start to see more feedback loops from the system, tighter feedback loops that we can then engineer. And I sometimes call these things mechanisms because we can scale these feedback loops across an organization. What usually happens in the adoption phase is everyone's getting familiar with chaos engineering. That's done on a small scale. And then we start to take the same mechanisms that are working there and roll them out across the organization. I think the largest organization I've worked with was approximately, I think it was about 600 teams was the eventual adoption story for chaos engineering. And every one of those teams was doing chaos engineering. It does introduce a whole host of other problems. One of the key things that's a big part of that system working, a mechanism that works there, something called safeguards. And we'll talk a bit more about that in just a moment. So in terms of how it all comes together and works, you write a chaos experiment. This tells you about some surprising elements in your system. We call these things dark debt. In any sufficiently complex system, there is dark debt that exists that you can throw a light on with chaos experiments. We can then learn from those things. That's a very summarized version of learning. Learning is not as simple as an icon, I'm afraid, but we can learn from those things. Some of that, by the way, can just be getting over the fact it's all happened. Then we can go ahead and test. So test is different from experiment. A chaos experiment is exploratory. It's most close to exploration testing. You're trying things out because you want to know something. You have a hypothesis, usually a technical hypothesis, and you're trying it out to see how the system responds in comparison to that hypothesis. So a hypothesis usually goes along the lines of, I believe the system will respond this way. And then you go, if I do these things. And then you do those things and you measure the hypothesis and go, no, it's surprising. It doesn't quite respond the way I think. So very technical. A chaos experiment is very technical, but it gives you that framing of we are trying to explore a hypothesis. A chaos test is really the same implementation as a chaos experiment, but the goal changes. The goal changes to one of validation. Have we overcome any weaknesses we saw? Can we use the same automation that we had in the experiment, but now do it for purely validation purposes? And I see this a lot. I see someone having constructed an experiment for a game day, perhaps to set up the game day, and then they take it with some small tweaks. It then becomes the test that they then use perhaps over and over again in the future, which leads them to a sort of a continuous validation, a scheduled validation of that automated test that was an experiment, but now we're using it to prove that the systems, actually those improvements we applied are applicable and still are applicable today like they were yesterday. One way of thinking about the difference between experiment and test is in experiment, we tend to celebrate a failure. We celebrate finding something. With a test, you're usually not celebrating a failure. You're usually trying to just build confidence that those conditions and failures you saw before are no longer present. So it's an emphasis difference between the two, but implementation-wise, they tend to be the same thing. Okay, so it's a very simple learning loop, simple mechanism to roll out. Why is doing this particularly difficult with organizations? Well, the first thing is the mindset is pretty tricky. Getting people to think this way and value doing proactive exploration of reliability and security, both concerns can be applied using chaos engineering. It's pretty tricky to convince people. It's also tricky because most experiments are highly technical in their nature. The hypothesis is not usually easily tied to some business concerns or stakeholder concerns. So there is a sufferance here, is that some of it is it doesn't help you justify the investment as much as it could. It's also worth mentioning that one of the big difficulties is doing chaos engineering obviously requires a tangible and considerable investment to do this. You need some tools, although often you don't need many tools to get started. In fact, I often tell people you just need a shell and then you can start. You need a discipline in the person, not the tool at that point, but you can start with a shell. But it requires people to think that resilience is important and worthy of an investment, particularly when you're going from a small team of people starting to see value in this and then cross an organization. And so those are the sort of common difficulties for convincing people. There's also some common challenges. And this is where I have to confess something. Because I helped implement the Chaos Toolkit. I helped to found it way back in the day. It's one of the popular open source chaos engineering tools. And I think we missed a trick. At least with severe hindsight, we missed a trick. So let's look at the construct that is a chaos experiment to understand this. A chaos experiment tends to be made up of certain components. It tends to have some sort of steady state hypothesis, which is this is what normal looks like, and this is what we're going to compare against. So we expect things to remain normal when we do some sort of method, which is failure injection and pieces that will be done. And then sometimes you might have, for diligence, a little bit of cleanup or a best attempt at cleaning up the system with rollbacks. And the flow of execution is typically, let's look at the system, see is it normal? If it's normal, do the stuff to it. If after we've done the stuff to it, does the system look like it stayed within tolerance? And then that's learnings. If it didn't, that's, celebrating a failure, celebrating something we've discovered. And then finally, we throw some rollbacks in to make sure we try and do our best efforts to put things back the way they were. Now, on the surface of this, nothing seems wrong here. But the problem I face is that it's extremely technical. It's a bit like TDD versus BDD here, right? We see most experiments that are very hard to justify to the rest of the world, and particularly some experiments that focus so much on making failures or turbulent conditions happen. Everyone, even our tooling, the tooling in the Chaos Toolkit, it tends to overemphasize the turbulent conditions to be applied to the system. Now, in hindsight, I think that's a bit of a mistake, and I'll talk a bit more about this in a minute. But I think really we should have looked closer at the steady state hypothesis and realized that there's huge power in making the steady state hypothesis much more relevant to more stakeholders. You only realize this when you start to roll chaos engineering out across a larger group of people, or if you're trying to convince a board to do it for the first time, in fact. Because if you start to show very technical hypotheses and experiments, the general reaction that I tend to get is, this is great, but why are we doing it? What confidence does it truly build? And the problem gets worse. Now, before I get onto the problem getting worse, let's just talk about the fact I have an excuse and a saving grace in all this. I'm not the only one that went this way. Almost every tool on the planet, as far as I can tell, that calls itself a chaos engineering tool has done this as well. I was not alone. So I'm okay with that. But it meant all these tools don't solve what has been realized, which I've realized over the last year or so now, what the hard problem of chaos engineering is, which isn't fault injection. It's not automation. It's not even really making things safe. Tools now have safeguards in. I mentioned these things earlier. They're very trivial. What they are ways of interrupting experiments based upon conditions if they're encountered. In the Chaos Toolkit, we have a high degree of flexibility about where you can interrupt and what you can trigger an experiment if things start to go awry. So you can think of it as guardrails or safeguards for your experiments. That's a crucial thing. It's built into lots of tools now. Fizz, for example, FIS from AWS that does fault injection in their systems also includes safeguards now. It's great to see that tool also embrace it as well, because it's a key pattern for scale. If you've got multiple experiments running at once, you need some way of saying to them all, stop. You need some way of saying, perhaps if one's running, don't run the others. So this sort of control plane, which some people call safeguards of experiments, is absolutely crucial to the safety of the experiments. But even that isn't the hard problem. The hard problem really is only obvious when you see people try and practice chaos engineering on a daily basis. And it's really this: what experiments should I even create? And this is so frustrating a question, because I still do loads of chaos engineering courses around the world, virtually at the moment, of course. And when I do them, this is always the hardest starting point, is what experiments should I even consider? Lots of people start with, okay, what have I seen before? Should I write experiments that recreate conditions that have hurt us before? That's a pretty reasonable place to start. And there are lots of starting points in the book where I talk about how you can brainstorm around what makes you feel uncomfortable about the system. You can start to question what you think you know. Those can lead to experiments. But when you practice all of these different techniques to come up with your experiments, you come up with highly technical experiments. And the technical nature of those experiments means it's very, very hard to prioritize which experiments to do, which experiments you're going to get the most value out of doing, which is the learnings from them. And that's a big problem, because lots of people do experiments and they don't really have a good reason for why they picked one experiment over another. And that's become an issue, particularly when you want the learnings from those experiments to be valuable, to be popular. One of the best measurements of success in chaos engineering is how many people are reading the findings from your game days and experiments. If no one's reading these things, you're wasting your time. And I see that frequently. I see it with incidents, whole incidents with systems where they create an incident report and then you look statistically at how often it's been read by who, and you realize it's not read by many. Well, that's the measurement of success of these things. Who's reading and consuming what you found out? And the problem with chaos experiments, if they are only technically bounded, if they are constructed based upon technical explorations, it's hard to make the findings super attractive for everyone to read. So we end up with this gap where we have a gap between what matters to the world, what matters to your company, the reliability, the concerns about reliability, and what you end up doing with your experiments is only capturing what can we explore. And so this has been a problem I've wrestled with now for probably over a year, but I've come to some answers for it, which I want to share with you today. And all of them came from a really, 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 really unlikely source. It came from reading this book because I was running a company and I needed a management philosophy for the company, and OKRs were really useful. I don't know, normally if I was there, I'd ask who's using OKRs. Also, I'd ask who hates OKRs, because people tend to love or hate them. It's all right, it's fine. Doesn't matter if you hate them. The story is here is OKRs are one mechanism to focus on measuring what matters, so that you focus on doing the things that have the biggest bang for your buck. Right. That is actually what we want for our chaos experiments. Now, we can't use OKRs because they're far too broad and they're not designed for the purpose of this. What we can do is look for something that is similar in reliability, and SRE gives us an answer here, or at least it positions an answer for us, which is SLOs and SLIs. SLOs and SLIs are OKRs for the reliability of a system. And what I've been doing for the past year is realizing this and going, okay, can we combine experiments that can tend to be highly technical in their steady state hypothesis and the value that they then produce in their findings? If we can combine that with SLOs and SLIs, do we find these things are more valuable? That was my hypothesis, if you like. If we do this job, if we relate our experiments to these other constructs that we've gone to the effort to define. And by the way, it doesn't matter if you're doing SRE or not. SRE is a whole working approach and culture that I think is excellent. But even if you're not planning to make that leap, SLOs on their own are super, super powerful. By combining them, however you get to them, by combining them with your experiments, what you end up is taking what the SLO and SLI is measuring what matters to reliability. You combine them with your chaos experiments, And you move away from purely experiment to prove hypothesis to exploring the impact on something that matters. It's a very subtle difference, but it changes the game for how people look at chaos engineering. It's no longer in a vacuum of exploring technical measurements and hypotheses. It's exploring real impact on things we care about, things that matter. So it also is useful when we're deciding what experiments to write at all. So what experiments should we write? Right, what SLOs have you got, and can we explore impact on those? Let's start from what matters and then go to we can explore factors around it. It's a bit of a game changer, because if you start from what do we technically worry about, you end up with technical hypotheses and experiments. But if you start from the collaborative creation and communication and work around an SLO and SLI and SLIs, you can end up with a much more powerful moment where everyone can go, we're doing this experiment because we care about this. And this is where I changed the name a little bit. It's no longer purely just experimentation. We're verifying the impact on the SLO. This is the how of what verification means to me. And it's a small evolution of the learning loop, the chaos engineering promises. It's a small change to this mechanism. This still exists and still is used by many, many people. But I also encourage people to take some of their experiments and move them over into verifications, to make them related to something like SLOs, to relate them to something that's more of an objective measurement of reliability on the system, rather than purely technical measurements as they're often related to in terms of steady state hypothesis alone. And I can't overestimate, or I can't overpromote really, just how huge this has been, because it's made my life easier. When I'm talking to people about what experiments to worry about, I start from what does good look like? Show me your SLOs. Or maybe I don't use that term because maybe they don't call them SLOs. Show me what good looks like. How do you measure good? Admittedly, I've had a few funny moments in my last 4 years, I think, where I bumped into organizations where I said, how do you measure whether the system's working? And the response was, when the customer's call, it's not working. Admittedly, not the best SLO to have in place. But frequently, when I work with people on chaos engineering, my work now often starts with, can we work towards something of an SLO and SLI style system? So that gives us a much better foundation to experiment based upon the context of what matters, what actually matters to reliability, to your world. So this is what, when we look at what makes a successful chaos experiment, it could be said to be the learning, the incident report, like I said earlier, the popularity of the incident report from your game day, or whatever you kick out as an artifact. But if you do it with SLOs, you do it with meaningful context as well. Your experiment isn't in a vacuum. Your whole findings are not in a vacuum. You have the reason and the value of doing this because it's tied to what you define as valuable reliability and security for your system. So it's always the learning. You end up with learnings really that matter. Okay. The last thing I want to leave you with before I think we might have some time for some questions. I hope we do. But the last thing I'll leave you with is related to safety. I mentioned safety earlier, and I mentioned safeguards. Safeguards that are tied to technical analyses, really, whilst an experiment's running to see whether it should continue running, are fine. They work great, and lots of systems incorporate them. But there's nothing to stop you implementing safeguards based upon, once again, the SLOs and the things that matter. You can turn an experiment off based upon the fact that an SLO or the measurable SLIs for an SLO are beginning to trend in the wrong direction. Maybe you are having more impact than you thought. Your blast radius is bigger than you thought. That is something you can trigger. You can take the same safeguard mechanisms, like I say, that tools have, but now if we relate them to SLOs and SLIs, rather than purely technical connections, if you will, we get even more safety because the safety is contextual as well. You end up with something I call safeguards that also matter. And just before I finish up, we're only just getting started with realizing just how powerful this is. So most of the organizations I'm working with now have started to bring SLOs into their game. Not always because they're doing SRE at all. That's entirely fine. That's not my purview. I'm not here to help people do SRE necessarily. What I am there is to take advantage of how we do chaos experiments as safely and as valuably as possible. And the combination of something like an SLO with good underpinning SLIs combined with chaos experiments is, we've only just scratched the surface of how valuable this is. I've seen people learn more. I've seen the learning loops be so much richer. I've seen top-level management be able to understand a chaos experiment's findings because it's related to an SLO that they understand. All of these things are beginning to be proven, and I can't wait to share hopefully more in other books and bits and pieces over time. But there's also a huge amount to be done here around SLOs anyway, because SLOs are an underexplored resource. See, chaos experiments don't exist in a vacuum. They exist in they work on a system, and they may cause surprising outcomes. SLOs at the moment are often written and created and constructed in ways where they're seen as islands. They're seen as isolated points. I'm seeing the signs that tooling is going to be able to support this soon, where SLOs can relate to one another. So you can get a picture of what reliability looks like across your system. And then you can see how an experiment can affect more than one SLO and how these things can be coordinated. That's a big thing for safeguards. It's a huge thing for just exploring. One experiment could explore the impact on multiple SLOs. And then if we understood how we thought they were related, then that would also give us even more value in our learnings as well. Okay, so quick summary. Simple hypothesis-driven chaos engineering is hopefully what you're all going to start with probably, and it's a great place to start. Technical hypotheses, nothing wrong with them. But if and when you're ready to, adding SLOs into the mix to give you meaningful context to safeguards and your hypotheses and your experiments, it's a massive boon I'm seeing it being a massive boon to the conversations that chaos engineering's findings lead to. So yeah, hypothesis-driven experiments based on SLOs, it's become a secret sauce. Not so secret now, because I've just told you, but it's something to bake in and consider it. You don't have to start there, but as soon as you do have the beginnings of SLOs in your world, you can start to attach them to your chaos experiments and get so much more out of doing this practice. Tooling is catching up. There's some stuff out there from Reliably that does some of these bits in Chaos Toolkit. I expect other tooling to do it as well. I'm really just trying to make sure everyone understands the super value you can get out of the learning from chaos engineering when you tie it to meaningful context. So although it's kind of in these tools at the moment, it's beginning to be there, I expect it to come in other places too soon. Okay, and that is me. Thank you for listening in wonderful Switzerland. I wish I was there. I truly wish I was there, but hopefully I'll be there next year. And I hope it's been useful. Follow me on various things like Twitter and LinkedIn or whatever, and there'll be articles that show much more detailed how this has been done in all sorts of places. But hopefully I'll be a bit excited about chaos engineering, and then you understand the value of relating SLOs to your chaos experiments. And I'll stop there, and I don't know if we have time for questions, but I hope we do. Thank you very much.